All right, counting significant figures, level 1, part 2. We're going to look at rules 3 and 4. Our learning goals, again, correctly count significant figures for simple numbers, including those with leading or trailing zeros, and identify which digit is uncertain. So recall rules 1 and 2. All non-zero digits are always significant. Zeros appearing between significant digits are also significant. On to rules 3 and 4. Rule 3, leading zeros are never significant. What's a leading zero? If we have a decimal point, we have 0.00, and then we have some non-zero values, those zeros I just mentioned, the one before the decimal point and all zeros before you get to the number, those are leading zeros and they're not significant. Leading zeros are always placeholders. They are not measured digits, so we don't count them. 0.13 has 2 significant digits. The 0 is not significant. 0.00396 has 3 significant digits. The 3 leading zeros are not significant. 0.00006 has 1 significant digit. None of those leading zeros are significant. 0.091 has 2 significant figures. 0.00552 has 3 significant figures. 0.05 only has 1 significant figure. 0.0406 has 3 significant figures. The 4 and the 6 are both non-zero digits and they're significant, and the 0 appears between 2 significant digits, so it is also significant. Now you can recognize placeholders because taking them away would change the value of the number. So the idea of placeholders also applies to Rule 4. Rule 4, trailing zeros are significant if and only if there is a decimal point. Otherwise, they're placeholders. If there is no decimal point, zeros at the end of a number tell you its magnitude. They tell you how many powers of 10, but they are not measured digits. You can tell they are placeholders because taking them away would change the value of the number. 100 has a 1 and 2 zeros that are placeholders. If you took away those 2 zeros, you would have 1, okay? This is not 1, this is 100. So taking those zeros away would change the value of the number. Therefore, they are placeholders. The quick way to tell is that there's no decimal point, and 100 has only 1 significant digit. 93 million. There are 6 placeholder zeros. There's no decimal point. There are only 2 significant figures, the 9 and the 3. 5,000, only 1 significant figure. All those zeros are placeholders. 410, 2 significant figures. 94,700, 3 significant figures. So the second part of this, trailing zeros are significant if and only if there is a decimal point. So we just saw a bunch of examples with no decimal points. If the number includes a decimal point, then zeros at the end are not placeholders. They don't change the value. So they are included because someone measured them. 1.000. This says that we know that this number is exact to the 1,000th place. There's 1 unit, 0 tenths, 0 hundredths, 0 thousandths. 430.0 has 4 significant figures. Sorry, 1.000 has 4 significant figures. 201.00 has 5 significant figures. Decimal point makes the trailing zeros significant. 11.40, 4 significant figures. 29.0, 3 significant figures. 4.720400. So the first 0 is a sandwich 0. It's between 2 other significant figures, but the last 2 are trailing zeros with a decimal point, and those are significant because trailing zeros are significant if there is a decimal point. So let's look at some mixed up cases. And what we're looking for is there a decimal point? And just to make remembering this simple, just think decimal point more. More zeros count if there's a decimal point. So we're going to determine whether the zeros should be included in your count of sig figs based on whether they're placeholders or not and how many sig figs we have. 9.00. There's a decimal point. These are not placeholders, so those zeros should be included, and we have 3 significant figures. 650. No decimal point. These zeros are placeholders. This 0 is a placeholder, so 2 significant figures. 4.800. Decimal point. Trailing zeros are correspond to measured values, so we have 4 significant figures. They're not placeholders. 220.0. Again, there's a decimal point. The zeros are not placeholders. They're 4 significant figures. 2,000. No decimal point. These zeros are placeholders. If you took all the zeros away, you'd have 2. 2 is not equal to 2,000. So they are not significant. There's only 1 significant figure, and that's the 2. 2,000 with a decimal point. This has 4 significant figures because the decimal point makes all of those zeros significant. 41,000 has 2 significant figures. No decimal point. Trailing zeros are not significant. And 37.0, 3 significant figures. With the decimal point, the trailing 0 is significant. All right, some examples, all the rules all mixed up. For practice, tell how many significant figures in each number. 114 has 3. 76,000 has 2. 4,007 has 4. 0.0061 has 2. 81.43 has 4. 3.70 has 3. 8.7124 has 5 significant figures. 6,000 only has 1. Those zeros are not significant. They're placeholders. 5.63 has 3. 0.6300 has a leading 0, which is not significant, and 2 trailing zeros, which are. So that's 4 significant figures. 0.405 has 3 significant figures. 9,200 has 2 significant figures. 500.0 has 4 significant figures. All those trailing zeros count because there's a decimal point. 500 with a decimal point has 3 significant figures. Both of those trailing zeros count because there's a decimal point. 500 with no decimal point has 1 significant figure. All right, summary. Sig figs means the number of digits in a value that are measured or estimated. We can recognize them by these rules. All non-zero digits are significant. All zeros between non-zero digits are significant. Leading zeros are never significant. And trailing zeros are significant if the number contains a decimal point, but not if it doesn't. The last significant digit in any number is always the estimated digit.